Capable of immobilizing a soldier for the rest of his life, landmines have been used in every armed conflict since World War I. However, even after the UN prohibited anti-personnel mines in 1997, unexploded landmines remain in the ground, posing serious threats to civilians. There are several techniques to detect landmines, including metal detectors, dogs, and rudimentary sticks. But they come with a host of problems. Metal detectors can detect false positives, and dogs and using sticks have the problem of user error. So what is the alternative? Scientists are considering using principles of VSEPR theory, hydrogen bonding, and fluorescent polymers to identify explosives. To understand what VSEPR theory is, think of electrons like books on a shelf. Bonded electrons are like books that are tightly packed together, while lone pairs are books that are not. The lone pair books will take up a lot more space than the bonded ones. This is what VSEPR theory states, that lone pair electrons take up more space than bonded electrons, affecting the molecule's bond angles. For context, polymers are large molecules made by linking together many smaller molecules known as monomers. Some have fluorescent properties, making them useful in detecting chemicals. What's cool is that the properties of polymers and principles of VSEPR theory can help us find landmines. To do so, a molecule known as polymerized urea is used. When acetone, a chemical used in explosives, is present, hydrogen bonds are formed with the oxygen atom of acetone. When this happens, the hydrogens are pulled closer to the oxygen, making the nitrogen-hydrogen bond act more like a lone pair. As we know, lone pairs take up more space than bonds, resulting in changes in the bond angles between the polymer and the nitrogen. This affects the polymer's fluorescence, changing its color and detecting the explosive efficiently. So the next time you find yourself walking in a minefield, remember this video, so you don't end up like this guy.